over section 8.3, Methods of Proving Triangles Similar. After studying this section, you'll be able to use several methods to prove that triangles are similar. Now in this section, we'll present ways to prove that triangles are similar. We'll first start with this postulate. If there exists a correspondence between the vertices of two triangles such that the three angles of one triangle are congruent to the corresponding angles of the other triangle, then the triangles are similar. And this is AAA similarity, because I know the definition of similar polygons is if I have three angles that are congruent to the corresponding angles of the other triangle, then I would have similar triangles. The following three theorems will be used in proofs such as side, 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 angle, hypotenuse leg, and angle, side were used in proofs to establish congruence. So if there exists a correspondence between the vertices of two triangles such that two angles of one triangle are congruent to the corresponding angles of the other, then the triangles are similar. This is AA similarity. I know that if I have two angles of one triangle congruent to the corresponding angles of the other, then I would have the third angle congruent to the corresponding angle because of no choice theorem. So this is really AAA, but a shorter version. Now, most of the proofs that we'll see will rely on AA similarity. Now, my next theorem, if there exists a correspondence between the vertices of two triangles such that the ratios of the measures of corresponding sides are equal, then the triangles are similar. And this is side, side, side similarity. I know in the definition of similar polygons, if the ratios of the measures of the corresponding sides are equal, then I have similar polygons. So if I can show this, then I would have side, side, side similarity. Now my last theorem, if there exists a correspondence between the vertices of two triangles such that the ratios of the measures of two pairs of corresponding sides are equal and the included angles are congruent, then the triangles are similar. And this is side, angle, side similarity. So if I have that side AB over side DE is equal to side BC over side EF, and the included angles, which would be angle B and angle E. So my sides are in proportion to one another. Those ratios are equal. And then I have the included angle congruent to the corresponding angle. Then I would have the triangles congruent by side, angle, side similarity. Now looking at our sample problems, given ABCD is a parallelogram, I want to prove that triangle BFE is similar to triangle CFD. So this triangle here is similar to this triangle here. Now we just learned our three theorems about similarity. We have AA similarity, we have side, side, side similarity, and we have side, angle, side similarity. So if I can show one of these three ways, then these triangles would be similar. So looking at my given, I have ABCD is a parallelogram. Well, ABCD being a parallelogram would tell me that the opposite sides are congruent. In this case, that doesn't help me because I don't have any other pieces, so I couldn't use subtraction or addition or multiplication or division or anything like that. It tells me that opposite angles are congruent, but notice triangle BFE is an inside of my parallelogram, so that's not going to help me. It does tell me that the opposite sides are parallel, so side AB would be parallel to side DC. And notice DE could be a transversal of this line. If DE were a transversal of this line, then angle CDF would be congruent to angle BEF because those are alternate interior angles. So that's one angle that's congruent. Now I need to show another angle congruent. Well, based off my diagram, I have angle BFE congruent to angle DFC because those are vertical angles. So now I have two angles congruent to the corresponding angles of the other triangle. So I'd have AA similarity. Now looking at this in my statements and reasons, first I'd have my given ABCD as a parallelogram. Then we stated that AB is parallel to DC because opposite sides of a parallelogram are parallel. Then we stated my alternate interior angles. So angle CDF is congruent to angle E. Parallel lines give me alternate interior angles congruent. Then we had angle DFC was congruent to angle EFB because vertical angles are congruent. Now my triangles are similar by AA similarity with steps 3 and 4. Looking at problem 3, we're given that KH is the altitude to hypotenuse GJ of right triangle GHJ. I want to prove that triangle KHJ is similar to triangle HGJ. So this triangle here is similar to the big triangle here. Now let's look at our givens and derive some information. Now I'm given that KH is the altitude to hypotenuse GJ. That would tell me that these two angles are right angles. If angle GKH is a right angle, that means that that triangle is a right triangle. And I'm also given that triangle GHJ contains a right angle. So if I show that these angles are congruent because they're both right angles, and we know that right angles are congruent, that gives me one angle. Now, when we had my triangles overlapped, I could see that they both share one angle, that angle being angle J. So angle J is congruent to angle J by the reflexive property. Now both of my triangles have two congruent angles, therefore they're similar by AA similarity. Now looking at this in my statements and reasons, first I'd have that KH is the altitude. Then we stated that HKJ is a right angle because altitudes form right angles. Now we need to show that GHJ is a right angle because it's part of a right triangle. Then I have that all right angles are congruent, so these two angles are congruent. Then we stated that angle J was congruent to angle J by reflexive, and now my triangles are congruent by AA similarity with steps 4 and 5. Looking at problem 4, the sides of one triangle are 8, 14, and 12, and the sides of another triangle are 18, 21, and 12. Prove that the triangles are similar. So here I'm given all three side lengths of both triangles. I know in similar triangles, the ratios of the corresponding sides are equal. So if I can show this, then I would have similar triangles. So I need to match up the corresponding sides. Now the corresponding sides will match up based off of their size. So the smallest side in my first triangle is 8, then the smallest side of my second triangle was 12. This ratio should be equal to my medium lengths, which is 12 of my first triangle and 18 of my second triangle. And then my biggest side is 14 and 21. If these ratios are all the same, then I would have side, side, side similarity. So I want to simplify each one of these ratios to see if they are the same. 8 over 12, I could take out a 4. This would simplify to 2 over 3. 12 over 18, here I could take out a 6, which again would simplify to 2 over 3. And then 14 over 21, here I could take out a 7, which again would give me 2 over 3. So I have all my ratios equal, so this would be side, side, side similarity, and that's proving the triangles are similar.